Okay, hello and welcome to my first YouTube video. I'm going to be doing a series on aerospace propulsion. So a bit about me. I'm an aerospace engineer and math and computer scientist. I teach at a university in Australia. My interests are autonomous systems, space systems, swarm dynamics, and optimization. You can contact me via the comments below, or I might set up an email for this later depending on your interests. So about this series, I'm going to introduce you to aerospace propulsion. Aerospace is an amalgamation of the words aeronautical and space, essentially inside and outside the atmosphere. The basics and an in-depth analysis of some core types of aerospace propulsion, and then we'll look at some advanced and future technologies. So the different types of aerospace propulsion. We have two classes, air breathing and non-air breathing. Essentially, one uses air from the atmosphere, the other one doesn't. As you might expect, air breathing is an atmospheric based propulsion system, non-air breathing generally used in space. Although you can use non-air breathing in the atmosphere. So you can see that we've got, under air breathing, we've got high-speed engines, piston engines and turbojets. Non-air breathing, experimental and future systems, electrical and electromagnetic, and the chemical rockets. There are more than this. This is not an exhaustive list, but at this stage we'll consider these. So the air breathers, the turbojet engine, mostly now used in older military aircraft, not so much in modern aircraft. It's the basis of all modern air-breathing propulsion. It is, however, quite noisy and less efficient. If we show you here, we've got the inlet. This section here is the compressor. Then we've got a combustor, a turbine, and then an exit or a nozzle. So the way this generates thrust is by taking in air, compressing it, blowing some stuff up, so adding some fuel, some heat, taking some energy out to run our compressor, and then firing very quick gas out the back. This one is a turbofan engine, so that's based on this turbojet engine. These are used in all modern airliners because they're a lot more efficient and a bit less noisy. Basically we have a core turbojet, which is this, squashed in here. Then around the outside we have this big duct and this giant fan at the front. So this engine is mostly used to run this fan, produces some thrust, but a lot of the thrust is produced by this bypass section. So these are also called a bypass engine. Okay, other air breathers. The turbo shaft is based on the turbojet again, but instead of using high-speed gas for thrust, we use a shaft, spins the shaft at high speed, so we attach a propeller and generate thrust that way, as in a turboprop aircraft or in a helicopter. They're most commonly used in helicopters. They're also used for power generation, but that's not really in the scope of this course. We've got the piston engine, the original propulsion system, used for about the first 40-50 years of propulsion in aerospace. This is a V8 in a star configuration. So, because a lot of early engines were cooled by air, they needed to spread them out like this. They're still used in a lot of smaller general aviation planes. They're quite heavy and inefficient. The high-speed ones. So we've got the ramjet, looks like this. So obviously you can see that there's no longer this compressor, combustor, turbine, exit stage. Now there's just this spike at the front, big empty section, and it goes out the back. So these are used at supersonic speeds, so that's faster than the speed of sound. The disadvantage is they have to be going faster than the speed of sound to start. They have very few moving parts because they use this to compress the air, then they just burn it in here and exhaust it. Combustion in these takes place at subsonic speeds, so faster than the speed of sound coming in and it slows down, and then in here it's going less than the speed of sound, and then it gets exhausted at faster than the speed of sound again. The scramjet is based on the ramjet, but it's used at hypersonic speeds, which is faster than Mach 5 or 5 times the speed of sound. They're highly experimental. NASA's been testing one for the last couple of years. I think so far they've got about 9 seconds out of it. They're very similar to ramjet engines, so essentially they look quite similar to this. They all have different structures, but in this case, combustion occurs at supersonic speeds as opposed to the subsonic speed, which we're using here. The non-air breathers. So we've got the chemical rocket. Everyone's seen a space shuttle. That's a chemical rocket. They're used in space propulsion mainly, also used on missiles and those sorts of things. They react fuel and oxidizer and produce a high-speed exhaust gas. Quite simple. There's two types. We've got solid and liquid rockets. We'll go into that later. The electric and electromagnetic propulsion systems. Now, it does look a little bit like something from science fiction, but they have been used on spacecraft for quite a while. They're actually quite an old system. They're still experimental, they're still improving them, but they are very efficient. They produce a very low thrust though. So while this is less efficient than this, it produces a huge amount of thrust. This can only produce fractions of a Newton or a Newton of thrust. They're usually only used in space. So the non-air breathers, the experimental types. Solar sails, nuclear fission, gravity tethers, magnetic, beam powered. So we've got a solar sail here, magnetic, beam powered. They might all sound a bit sketchy, a bit like science fiction, but they've been used in various experimental crafts for the last few years. There's still a lot of ongoing research into them. So that's it for the introduction. Next time we're going to take an in-depth look at turbojet propulsion. I hope you enjoy it. Leave some comments.